All right, so in this video, we're going to go over some mechanisms and how to determine the energy diagrams of them. So let's try these questions on this homework assignment. So there are two steps. The first step, the NO2 is becoming NO and oxygen atom. That means we are breaking bonds. If we are breaking bonds, we need to provide energy. So that step must be an endothermic step. Okay, the first step must be endothermic. Why? We are breaking bonds. Breaking bonds requires energy. Okay, so when it comes to the options, we can eliminate option C and D because we see that in option C and D, the first step is not endothermic, it's exothermic. So therefore, those two are out. And then the next step, oxygen atom is combining with O2 or making a bond with O2 to make O3. So we are forming bonds. If you are forming bonds, it needs to be an exothermic step, right? And then we see that between A and B, the only exothermic step, the second step is exothermic only in option B. Therefore, option B should be our correct answer, not option A. Okay, so, and also if you look at the overall reaction, it seems to be an endothermic reaction. The reason is, I mean, if you add these up, the oxygen is cancelling out because it's an intermediate, and we have NO2 reacting with oxygen to go to NO and O3. Okay. So it seems like we have more AB bonds on the reactant side because we have nitrogen and oxygen, two atoms here on the reactant side compared to the product side. Therefore, the product side is weaker overall compared to the reactant side. That's why we are going from lower potential energy to higher potential energy overall as well. Okay, so the correct answer is option B. And then go back to this. Let's go to the other version. It's the same reaction, it's the other way around, but let's see, I mean, how to tackle this as well. Again, take a screenshot. The first step, we are breaking bonds. The O3 is breaking into O2 and oxygen atoms. So if you're breaking bonds, we need to provide energy. Therefore, that must be an endothermic step, the first step. Okay, why? We are breaking an O bond here. Bond breaking requires energy. We need to provide energy to break bonds. Okay, so, and then if you look at the options, option A cannot be our answer because the first step is exothermic there. Option B cannot be our answer. First step is exothermic. And option C and D, we see that the first step is endothermic. So those are going to be our options so far without considering step 2. And when it comes to step 2, we are forming a bond to make forming a bond here because we are the NO is combining with oxygen atom to give us NO2. So we are forming bonds, bond forming release, bond forming releases energy. Therefore, it's going to be an exothermic step. Okay, so for that reason, option C cannot be our answer. We see that in option C, the second step is endothermic. Okay, we are going from lower potential energy to higher potential, so that cannot be our answer. Therefore, it needs to be option D. Okay, where the second step is exothermic because we are going from a higher potential energy to lower potential energy. So therefore, that is our answer. And also, it's always a good idea to verify it by verify the overall reaction. Okay, so the overall reaction again here is oxygen atom cancels out because it's an intermediate. O3 combining or reacting with NO produce O2 and NO2. Okay, you see that we have more AB bonds on the product side because we have NO2 rather than NO here because we only have AB bonds in NO and NO2. But in NO2, we have more AB bonds because we have 2 AB bonds. meaning we have stronger bonds on the product side, meaning lower potential energy. So overall, we are going from a higher potential energy to a lower potential energy in this overall reaction, which is always a good idea to verify at the end. All right. So the correct answer is option D. So that's it. And those are the only homework questions we have about that. I hope this helps. I'll see you guys in class. Bye, everybody.